Welcome to SolidCAM Professor. I'm Sydney, your SolidCAM Professor, and in this session we'll be doing a lesson on creating chamfers on your parts. If we take a look at this part that we have here, we need to create a chamfer around these edges here and around the inside edges over here, as well as these stubs over here. So I'll simply go into my operation and start with a profile operation. Now my geometry will be this edge over here going all the way around, and this edge over here going all the way around as well. Now the tool that I will be using can be a 90-degree spot drill if I want, or if I want I can simply add a chamfer drill to that operation, and I'll use in this case a 90-degree 10mm chamfer tool to do those chamfers on the edge. Now when I go to my level area, I'm going to choose my upper level as a top surface over there, and my profile depth will be actually the edge of the chamfer itself, this line over there. Now when I go into my technology area, first of all I'm going to choose the option of finish in this particular case, but what's important over here is using the rest material chamfer option. If I were to open that up, you'll see we have the option there of chamfer. What's important in my data area is the cutting diameter. What is the cutting diameter that I actually want to use of the tool when it first makes contact with the material? And let's say, for example, I want to use the cutting diameter of 1 mm of the tool. Of course, now when I go into my links, I can have a lead in of an arc, and the same as lead out, same as lead in my lead out area. Now when I do save and calculate and simulate, I'll use my solid verify simulation. You'll note that my tool is going to go down, and I also want you to pay attention to the Z level that it's going down to. It's going to go down, do this one step at a time, and you see now that my Z level is at -1. In other words, it's going down for that 0.5 mm chamfer, is going down one extra 0.5 mm in order to create that 0.5 mm chamfer using the 1 mm diameter on the tool itself. Let's go one step further in, and as you see, this is the actual chamfer that's going to be done. This here is the actual 1 mm of the tool that's going to be used. Now go around on the part itself, and you see exactly what happened over there. Let's go back to our full view over here. Just continue to the very end, and we have this both now on the inside and the outside, getting the exact measurement of the chamfer that is needed. Now if I want, I can use a different type of tool. I can also use a taper mill, where my diameter of the taper mill itself will be 8 mm, and my tip diameter will be 4 mm, and have a 45-degree angle on the edge. If I were to use something like that, a tool like that, then when I go into my technology area and go into my data of my chamfer, I'll simply put the cutting diameter then, say at 5 mm. And now when I do save and calculate, and again use my simulation, you'll see again that the tool will go down, and this time when I do the side view, you'll see that this is the actual shape of the tool, and that's exactly what's going to happen over there. It's going to work, use that tool as well, and give us the perfect chamfer that we need for the part itself, and as we complete the entire part. Thank you for joining us on SolidCAM Professor. Take care and have a nice day.